Right, this just means and, or, not, and XOR. Okay? But what they're meaning, instead of them being used logically, so when we use these logically, we say some condition and another condition. But when we say bitwise, we mean applying pairs of bits, or in case of not manipulating a single byte or set of bits. Right, okay, so let's just work with 8 bits. Right, so if we've got an 8-bit pattern, and remember what I've always said to you, if you're doing this in the exam, you're writing down binary numbers, do it in nibbles. Leave a little gap, makes it easy for someone to read, makes it easy for you to read back. If you get asked to do hex, it makes it trivial. GCSE, yeah, because at GCSE they give you bonus points. No, at A level they go, you either got it right or you got it wrong. We've asked you to write in hex, just do it. We're not going to like pat you on the back for doing half of it. Yeah, so if I applied the bitwise operator not to this, so if I say apply not flips a bit, doesn't it? Okay, so all I do is I do it bit by bit, which is what bitwise means. All right, so I apply not to each one of the bits. So I just go flip, all the bits, flip. So if I do not of that bit string, that byte, that's my outcome. Okay, so that's simple. The other 3 are comparators, aren't they? They compare bits. So we need 2-bit patterns. So I'm going to use that one that I've just got. So let me just, because it's on the screen and I can see it and I can just copy it. So I am going to apply, and I'll do this first and then I'll talk about masks, which is what this relates to. And I'm going to do an AND. Alright, so I'm going to apply AND. Because it's bitwise, we go bits that are in the same positions, and we could just basically go AND. So we do and it doesn't matter which way up and down, it doesn't really matter, it's up to you. So all I do is I go, right, 1 and 1 is a 1 using AND, 0 and 1 is 0, 0, oh, 0, oh, there's a 1, we'll have 1 hand, 0, oh, 0, oh, 0. Okay, now, AND allows us, if we've got a pattern of bits and we want to set or clear some of those bits and make them 0, we can do this using an AND mask. So an AND mask is used for clearing specific bits. And in your mask, you put a 0. So place a 0 where you want to clear a bit and a 1 where you want to keep it the same. Okay, so you can see in this example we've got these 2-bit patterns. These ones here forced in our answer those 3 bits to be 0, even though there were 1 here. And then these 2 forced those 2. So that affected those 3 bits and those 3 bits. If you look at all the other ones, they're the same as they were. So it did not affect. So that one is the same. That one is the same. And that one is the same. So they stayed the same. So all these just got copied. So an AND can be used to clear bits. Okay, so we do this quite a lot in assembly language programming when you want to look at the lower nibble or the upper nibble. So you'd like put a mask in place to clear 1/2 of the byte. Okay, or even better is how you do mod. if I wanted to do mod 8, okay, so I'm interested in the numbers 0 to 7, I could do, so this is an AND mask. Well, that's an awful colour. Let me change it. Let's have that, which is not much better, to be honest. An AND mask to do mod 8. So with mod 8, the numbers that you're interested in are in the range 0 to 7. So what you get is you will put something together like this. You say, right, clear the upper nibble, but also the 8-bit, but keep those 3 the same. You can use this if you're doing counters. So you've got like a general count that's just constantly incrementing, and you just want to know when it's divisible by 7 or something like that, and you start doing the mods. So if I apply that to any number, so let's say I add the number, what should we go for? What number is that? Let's scroll it up. 16 plus 4, yeah, 22. Okay, so if I apply this AND mask to it, you can see that, yeah, those first 5 are just going to be zeros, and then we get that. So what number does that give us?
6.
Yeah. (22) mod 8 is 6. So it gives us a mod. So you can do, it's good for that. Right, okay, so that's AND. Is everyone happy with that? AND is clearing. Right, let's have a look at OR. Let's go back to black pen. So OR. Again, it's a bitwise operation. It requires 2 values. So let's have a look at a couple of bit patterns. Let's say I add this number, and I add this one, and I decide to OR those together. So I just bit by bit do the pairs. So I go 0 to 1, so wherever I've got a 1, I'm going to get a 1. So yeah, I've got a 1, oh, nothing there, nothing there, got 1, got 1, got 1, got 1, got 1. Okay. Right, so with an OR, wherever we set a 1 in one of the patterns of bits, we would guarantee ourselves a 1, no matter what was there previously in the other one. So what this is used is for setting. So it's called a SetMask. Yeah. Clear means set to 0. Well, don't use that word. Clear means making 0. Set means making 1. Okay. It's when you look at CPU instructions, they're often called be set or be clear or clear. Okay. So a set mask for forcing a bit to be a 1. I think I'm going to have to start a new board. It's getting slow this now. So wherever we put a 1, so place a 1 where you want a 1. Okay, so let's just look at an example of that. Let's say I want to set an upper nibble. I want to set all of it. So all the upper nibble of a number is 1. So the mask for doing that would be 1, 1, 1, 1. And I want to leave anything else unchanged. So I just put a 0 in the positions where it's unchanged. Okay, so if I get a data value come along that I want to manipulate, so let's say, so that's my mask. So we're attempting to set those bits. Oh dear, it's slowing down now. I'll start a new mirror before I do the floating point. So set these bits. So let's say this is my pattern that I am going to apply it to. So when I do this, remember it's all. So I say, oh, okay, they're all ones, so I'm just going to write those down as ones. But let's do this one properly. So I've put 0, so whatever was there is going to stay, and that's how all works, isn't it? So I've got, oh, naught and naught is naught, so that stays as naught. Naught and 1 is a 1. Naught and naught is naught. Naught and 1 is 1. So that's where they're left unchanged. But I've now forced the high bits to be 1. Right, the final one, assuming that the mural doesn't completely bog up on me now, is XOR. Okay, so again, it's a bitwise operator. So just give yourselves some bit patterns. It certainly does not like me. And when I apply the XOR, again, just in pairs. So you've got to remember XOR. When they're different, you get a 1 as an output. When they're the same, you get a 0. That's all it is. So they're different, so we get a 1. They're the same, so we get a 0. 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 They're different, get a 1. They're different, we get a 1. So being different is positive with the XOR, okay, or XOR to those people who like fantasy games. Right, okay, so what sort of mask does XOR give us?
Toggle.
It is the toggle mask. So XOR is for toggling. Yeah, but that's on a single data item, isn't it? Where XOR allows you, so with NOT, it's the whole thing gets toggled. With XOR, it's selective. So you can say what bits you want to toggle. Okay, so you can toggle independently different bits. NOT does a toggle of everything, which sometimes you do want to do, obviously. When you're doing two's complement, if you've got a system that hasn't got two's complement, you can use NOT and then add one. So, or NOT and then increment, whatever it is. So we toggle individual bits. Come on, keep going, mural. So you place a 1 where you want to toggle. What's nice about XOR is you can apply it twice and get back to the original item, which is why it's toggle. So place a 1 where you want to toggle. Ugh, come on. I've just got another couple of lines to do. I should have saved it and then binned it off and started a new one, but it's too late now. Right, okay, so let's say I want to toggle the middle 4 bits. So this would be a mask to toggle those. So I'll do it in different colour again. Let's go for whatever that is, medium orange, whatever that means. Right, so I don't want to toggle the 2 high bits, but I do want to toggle the 32 and 16 bit. And I'll do the 4 and the 8, and I won't toggle those. So these are the ones I want to toggle. In the pattern I'm going to apply it against. Okay? So I'm going to do it with this whole thing. So I've got that pattern of bits, whatever that represents, I'm not bothered what it represents. But I want to flick off those ones. So when I do my XOR, okay, they're different. Oh, let me do it in a different colour. Dark yellow orange. Pretty descriptive now. Right, 0 and 1 in XOR means they're different, so that stays as a 1. They're different, that stays as a 1. They're the same, so that becomes a 0. They're the same, so that becomes a 0. They're the same, so that becomes a not. They're the same, so that becomes a not. They're different, stays a 1. They're different. Okay? So that toggled those off. If I applied that again, okay, 0 and 1, they're different, get a 1. So it didn't affect it. So when I put the 0 there, it didn't affect it. I'll do another couple of examples. I'll show you one that's used. Okay? I get to this, 1 and 0, they're different, so it becomes a 1. So it will flick them back. Okay, so I'll just do that in another colour. So just applying this one and this one. So 0 and 1 gives a 1. 1. They're different, so that's a 1. Different, 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 different. Okay. Right. ASCII. What's the difference between upper and lowercase letters in ASCII? Yes, the 32, bit 5. Okay, so let's have a look. I love ASCII. If one could love a character set, ASCII I do love. Unicode, it's a bit too much for me, it's a bit full on. But ASCII, short and sweet. Right, let's have, just for testing your head's sake, you don't have to remember this because they have to give you it, but what's capital A? It is 65. Right, so 65 looks like this. Also very easy to write. So that's capital A. What is little a? It is 97. If you know one, you can work the other one out. Right, but that's this bit, isn't it? Bit 5 needs to change. So that was 65. We want to convert that to 97. I don't want to change the value, but I want to change that bit. What two masks could I use to force this to lowercase? So if I was to do in my code, if I was doing string comparison, I would want to force to lower or uppercase, wouldn't I, to make sure I'm testing well. So if I want to force this to lowercase and I want to do 2 lower, what could I apply? What mask? There's 2 masks I could do. I could do XOR. What other one could I do? If I want to set bit 5. What operator does set? OR. So I could do 2 different masks. So I could do an OR mask. So let's change colour. So let's do blue. So if I was to, let's do a darker blue than that. Let's do that one. Dark teal. Right, so I put a 0 where I don't want to affect anything. And I put a 1 on the 32, bit 5. So this would be force to lowercase. Well, let's just prove it by doing it. All right. So we get not or not is not. 1 or not is 1. Not or 1 is 1. Not is obviously not, so they're all not. And then 1 or not is. Said it and written something different. That's why you have to double check yourself in the exam, because your brain and your hands don't necessarily do the same thing. Mine don't anyway. Mine definitely don't. My brain and my mouth don't do the same thing. That's part of my problem in life. Right, okay, so that hopefully is 97. 64 plus 32 is 96. Nice number. Plus 1, 97. Right, but we could do an XOR. So what would we put as the XOR? What's the advantage of using XOR rather than OR? So OR's worked. But we could do X. What would the mask be for XOR? We're going back to the original one. What did I say? Where do you put the items you want to toggle, the bits you want to toggle? What do you put? A 1. Yeah? Right, so I want bit 5. Yeah, we're going back to the black one. I'll write it out again because I can. I'm clever. Right. So if I apply, let's just make sure it works. So we think if we toggle that bit, we're going to make it from capital to lowercase. Right. Let's just see what happens then. So let me change colour. Let's go for green. Right. So 0 and 0, they're the same, so we get a 0. They're different, so we get a 1. Different, so we get a 1. That looks promising. They're the same, so we get a 0. They're the same, so we get a 0. Same, so we get a 0. Same, so we get a 0. Different, so we get a 1. Right, so they're both doing the same thing. But what advantage has XOR got that OR hasn't? If I apply OR again to that, what do I get? So if I apply that OR, so if I say OR and I take my mask, did it in that colour, didn't I? So if I take that mask I did, which was 0, 1, 0, 0, 0, 0, 0, what value do I get? If I apply that mask to this 97, what do I get? You just get 97 again, don't I? What if I apply the XOR again? That's the advantage of XOR. So yeah, so if I just do that now, so I go, oh, they're the same, so that's a 0, different. Same, so that's a 0. Same, different. So it allows me to flick back and by just messing about with that pattern. A quick operation. I don't have to like do an if. You know that whenever we've had questions where they've gone, oh, how do you turn a number into an uppercase, lowercase? Well, you'd blow their mind if you just did XOR on it. And you just said XOR 32. That'll do it. That'll toggle it for you. Okay. So yeah, XOR is pretty cool because you might have two really weird numbers that are different. If you know what are different between the two numbers, and I did this on my Ghost Hunt game, I had two different tiles. I had a black tile and a blue tile, and I used it to animate the ghost's mouth when it's not happy. And it was tile 233 and tile 126. So I could have done an if and gone, if it's 126, now make it 243. But what I did instead is I worked out which bits changed, wrote a mask and just keep XORing it. No, I didn't have to do any work at all. Just said, right, next time it's time to do it, just XOR it. Wicked, really wicked. Okay, right, I'll stop the video there with me saying wicked for the third time.